Alright, so let's continue with HCF and LCM thing, and we discussed what is HCF in the last video. In this video, we'll be discussing what is LCM, right? So just like we took two numbers in the previous case, which were perhaps 10 and 12, and we found out what is the highest common factor of these two numbers. In this video, we'll be actually, instead of, making a list of factors, we are going to make a list of multiples, right? So let's make a list of multiples. So multiples of 10 are going to be 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and you can, just figure it out right now that I can just forever be going on and it will never end. So there's no point of actually continuing it forever. I could just stop right here. And let's actually do the same for 12. Well, the factors of 12 are 24, 36, and 48, 60, 72, 84, 96, 108, 120, 132, and you can just see again that I could just be going on forever. So if I want to find out, by the way, these are called multiples. I've just written down multiples of these two numbers. If I want to find a common multiple, these are multiples. If I want to find a common multiple, so common multiples are going to be the ones that are actually appearing in both, like 60, I can see right there that it is present in both of these, and also 120, which is present in both. So the common multiples are going to be 60, 120, 180 is also going to be there, and 240 perhaps, and there are going to be infinite number of common multiples. So since we are never, reaching to the end of these multiples, so we are never interested in the highest common multiple, but there is always going to be a finite and known lowest common multiple of these two numbers, which in this case is 60. So if we are interested in least common multiple, the common multiple that is present in both is also the least value, having the least value is what we are interested in. So LCM is actually the least common multiple that is present in both of the multiples, the list of multiples of both the numbers, and that's what we are interested in. And the official, or the standard way of finding LCM is do not actually use making lists down like these and spotting what number is common, but there's a way that we use that is similar to the one that we use for HCF, and that is to actually draw that tree thingy. So we are going to draw a vertical line and a horizontal line, and then write 10 and 12 like that, just like we did for the HCF, and then factorize it. So it is factorizable, or sorry, divisible by 2 and 5, and it is going to be 6 here, because 2 times 5 is 10, 2 times 6 is 12. And now we know that there's not another number which 6 and 5 are divisible by commonly, so we're going to stop here. So in HCF we just took out this 2, and which is the branch of this tree, and we call that to be HCF. In LCM we are also going to include the roots of this tree, which are the numbers that actually end up down there at the bottom, which are no more divisible by any other number. So we're just going to uh, multiply all these numbers together. 2 times 5 times 6, all the branches and all the roots, which is going to give me 5 times 2 is 10 times 6 is 60. So 60 is going to be the LCM. So the important thing that you need to remember about HCF and LCM are that you always need to factorize numbers like this, but the branch of that tree, or the product of branch numbers, the branch numbers is going to give you the HCF, and the product of branch numbers as well as the rooted numbers, the ones that appear at the root of this tree, like at the bottom, that are no more further divisible, the product of all these numbers is going to give you the LCM. So I hope it makes sense to you, and you understand how to find LCM, and you understand what is LCM and what is HCF, and you do understand how to find HCF and LCM of two or more numbers.